Hey guys, welcome back. Mr. Marone here. So welcome into lesson 7.3. It's a section on proof where we're going to be looking at similarity. One thing I just want to point out to you as we go through this, when we think back to our dealing with congruence, we used the symbol that was an equal sign with a little squiggle above it. And this really broke down into having similarity and then also having equality. So when we deal with similarity, the only symbol we're going to use is that one squiggle right there. So if you look in our first piece of info here, they're talking about two triangles and they've only got this single squiggle. That's indicating similarity. And just to make sure that we remember on similarity from our previous discussion, similarity means that it's going to have angles that are congruent, but our sides will be proportional. So that's what really we're looking for when it comes to similarity, and those are the relationships that exist. So we have three ways to prove similarity in triangles. The first one is known as angle-angle similarity. We talked about how we couldn't use angle-angle-angle to prove that two triangles were congruent. But if you have two sets of congruent angles, or three sets really, you automatically have similar triangles. The sides will be proportional. So if I've got two sets of corresponding congruent angles, then the two triangles are going to be similar. So the way that you verify this is by looking at the actual angles of the triangle. You need at least two sets. Once you have two angles, you can always find the third angle. So that's why we only call it angle-angle. We really don't need to do the extra work. If we look at example 1, they gave us that angle R and angle V were both 45 degrees. And from our knowledge of triangles and our knowledge of angles, we know that angle WSR and angle BSV are going to be congruent because they're vertical angles. Since I have two sets of congruent angles here, we can say yes, by angle-angle similarity, these triangles are similar. Using that same knowledge and all we've learned up to this point with triangles, can we tell that this second set of triangles is similar? I'm going to go ahead and pause the video and let you try it, and when you come back in, the answer will be there. Alright, welcome back in. So if you look closely, I did a little bit of arithmetic here, and just found what these two angles were down here. If my base angles are congruent, that means my vertex angle subtracted from 180 is going to give me each of those angles. So I did 180 minus 62, got 118, and when I divided that in half, that told me each of these angles were 59, which don't match these 68-degree angles. So no, they are not similar. We now are bringing back two abbreviations we've used in the past in side angle side and side side side. There's a little bit of a difference here, and there's a big, it's a little difference, but it's a big difference all at once. So if you notice first in the naming, it's side angle side and then the similarity mark. That's how we know that you're talking similarity and not congruence. And like we said with similarity, the angles are congruent, but the sides are proportional. So in order for this to happen, if I have two sets of proportional sides and a set of congruent angles, then I can use this method. So looking at our picture, as long as the measure of AB over QR is the same fraction as AC over QS, and those angles are congruent, then I have similarity. And then you would use side angle side similarity. You have to have that similarity mark. Our last one is side side side, and it's side 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 similarity. So it's the same having that similarity mark next to it. And really how this works is instead of three sets of congruent sides, you have three sets of proportional sides. So if I've got three sets of sides that are proportional, then the two triangles are similar. So taking a look at our two examples here, they want to know, are they similar? And if so, write a statement to state that they're similar. So if we look closely at these, I'm going to use my smallest numbers in each one. In ST, it's 6, and in VX, it's 9. And that's going to simplify to 2/3. So now, if I can't create two more fractions that have 2/3, this one was ST over VX, then we don't have similarity. So the nice part is, if we don't have similarity, it actually goes much faster. We're almost rooting for it to not have similarity. If I then pick the next largest numbers, I've got UT over VW, and that's going to give me 8 over 12, which does simplify to 2/3. So we're still on track right now. And then our last set here is going to be SU over XW. And when I compare those, I have 10 over 15, and that does simplify to 2/3. So since all three of them are proportional, then we can say yes by side, side, side similarity. Okay. In example 3, I'm going to let you try this, but I want to give you 2 pieces of information to see if you can kind of get comfortable with it. These are overlapping triangles. First of all, they both have letter K there, so that gives us a set of congruent angles. If I were to draw them separately, they would both have angle K. The second thing I'm going to point out is that the outside length of KM is actually 10 units, not 2 units. And then same thing down here. This one is 15 units, not 3 units. So go ahead and see if you can find proportions and see if these are similar. One last tip, since they gave us a set of angles, we're aiming to use side angle side similarity, not side side side. So go ahead and try that, and when you come back in, the answer will be there. Okay, welcome back in. So as you can see, I took KL over KM, and that gave me 8 over 10. And when I did KP over KN, I had 12 over 15. Both of those simplified to 4/5, which tells me by side angle side similarity that I have congruent figures here, or I'm sorry, similar figures here, similar triangles. So that's really it. There's 3 methods: angle, angle, side, 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 and side angle side similarity. Give it a try, and let me know if you have any questions tomorrow. Have a great day, guys. Bye-bye.